As AI systems tackle increasingly complex tasks, the limitations of relying on a single prompt becomes clear. Most real-world problems require multiple steps, evolving context and precise control, something a single prompt cannot reliably deliver. Prompt chaining solves this by breaking a task into a structured sequence of smaller prompts, each producing an output that becomes the input for the next step. This pattern enables stepwise reasoning, tools integration, and more predictable execution flows. In this section, we'll explore how prompt chaining works, why it's essential, how to incorporate tools into the chain, and practical use cases where it delivers reliable, production-ready results. The prompt chaining pattern is a powerful approach designed to help AI systems handle tasks that are too complex for a single prompt to solve effectively. At its core, it follows a divide and conquer strategy. Instead of overwhelming the model with one giant instruction, we break the problem into a series of smaller sequential steps. Each step in the chain is handled by a specialized prompt crafted for a special subtask. Once that step is completed, its output becomes the input to the next prompt, forming a smooth dependency chain where every intermediate result shapes and directs the next phase of reasoning. The pattern is foundational in modern agent architectures. It enables AI agents to plan, reason, and act across multiple stages, making them capable of navigating dynamic environments and solving complex workflows with much higher reliability. Relying on one giant prompt to handle a multi-step, multifaceted task may sound convenient, but in practice, it's one of the fastest way to break an AI system. Large overloaded prompts create too much cognitive demand on the model, leading to unpredictable behavior and unreliable output. A single prompt tries to squeeze analysis, reasoning, extraction, planning, choice making, and writing all at once. This forces the model to juggle competing instructions, manage long context, and maintain precision across many different subtasks, all within a single reasoning window. And the result, the model becomes overwhelmed and the quality collapses. So the key failure modes, and first, the instruction neglect. When too many instructions are bundled together, the model simply skips or incompletely executes some of them. It focuses on the part that seem most prominent or easiest to answer. The second is contextual drift. As the responses grows, the model gradually drifts away from the initial context. Important details get diluted or forgotten, especially in long tasks requiring sustained attention. The third is error amplification. One mistake early in the output cascades through the rest of the task, especially dangerous when later steps depend on earlier ones. Example, misreading a number leads to a wrong chart and a wrong summary. And the fourth is higher hallucination rate. The mental load of handling everything at once increases the chance of fabricating data, missing details, or inserting unsupported claims. We'll take an example scenario. So if you ask an LLM to analyze a 10-page report, then extract key metrics, summarize findings, identify patterns, and draft an email about the insights, you're essentially demanding five distinct workflows inside one prompt. The model might misread the data, miscalculate the trends, or produce a vague email, all because it didn't have the structured guidance needed to manage each step. So, single prompts break down under complexity. When tasks require precision, multi-step logic, or data-dependent reasoning, a single short instructions become fragile and error-prone. This limitation is exactly why prompt chaining exists and why it has become the cornerstone of modern agentic design. So prompt chaining solves the major pain points of single overloaded prompt by turning the process into a clear, structured sequence of steps. Instead of forcing an LLM to juggle multiple cognitive tasks at once, we break the workflow into smaller, dedicated stages, each with a narrow focus and a well-defined goal. This shift dramatically increases reliability. At first, each step of the chain is self-contained and easy to understand. If something goes wrong, you can inspect that specific link instead of guessing where the entire prompt failed. This modularity mirrors good software design, clean components that work together. The second, when a prompt has one job, the model becomes better or it works better. You're no longer competing for attention inside a massive multi-paragraph instruction. Each step becomes a finely tuned operation aimed at producing a specific high quality result. And the third, by easing the mental burden on the model, you minimize ambiguity and significantly reduce the chance of hallucination. The model thinks more clearly because you've eliminated unnecessary complexity. To illustrate, consider a three-step pipeline for processing a market report. The first is the initial prompt, basically for a market analyst role. Summarize the key findings and so on. The agent focuses solely on summarization, no trend analysis, no emails, just clean extraction of the core ideas. And suppose the second prompt is for a trade analyst role, where the prompt says, using the summary, identify the top three emerging trends and extract the specific data points and so on. Now, the model builds on the previous output, using it as trusted ground truth to produce deeper insight. And let's say a third prompt for an expert documentation writer role. And suppose the prompt say, draft a concise email that outlines the trends and supporting data, and so on. With all the heavy lifting already complete, now the agent composes the final communication with clarity and accuracy. Through sequential decomposition, even highly complex tasks become predictable, debuggable, and repeatable, unlocking production-grade reliability for modern AI agents. One of the greatest strengths of prompt chaining is its ability to blend reasoning with real-world capability. Instead of relying only on the model's internal knowledge, each step in the chain can instruct the agent to use external tools, whether that's calling an API, querying a database, searching a web, or pulling information from a document. This allows the agent to operate with up-to-date, verifiable information rather than static training data. But tool integration only works when the information flowing between steps is dependable. Reliability hinges on how clearly each step communicates its output to the next. Ambiguity becomes the enemy here. If one step produces vague or inconsistent text, the next step may misinterpret the content, causing the entire chain to fail. To counter this, each step must produce clear, consistent, and predictable output. So instead of long paragraphs, the agent should present information in a simple, structured manner like bullet points, short list, or label sections. This minimizes confusion and ensures that every step receives exactly the input it needs. For example, if the trend identification step identifies three emerging marketing trends, it should present them in a clean, clearly separated list. This way, when the next step or the email drafting step reads the content, it can easily extract each trend and build a polished, coherent communication around them. By combining tool uses with clean output formatting, prompt chains become far more reliable. Each step becomes both easier to debug and more trustworthy, forming a robust pipeline that consistently produces accurate and actionable results. Prompt chaining isn't just a theoretical technique, it has practical applications across a wide range of tasks where single prompt falls short. First, consider information processing workflows. The goal here is to take raw data and transform it step by step into a structured, actionable output, such as a polished report. A prompt chain in this scenario might look like this. First, extract text from raw document. Second, summarize the extracted content to capture key points. Third, identify entities like names, dates, or locations. Fourth, search knowledge bases to enrich or validate the data. And fifth, generate the final report combining all the processed information. Each step is focused and modular, ensuring reliability and clarity in the final output. And second, consider complex query answering, such as historical analysis or multifaceted problem solving. Some questions require multiple reasoning steps that cannot be handled in a single prompt. Here, a chain might work like this. First, identify sub-questions embedded in the main query. Second, retrieve information related to the causes of the events. Third, retrieve information about responses or outcomes. And fourth, synthesize a coherent answer that integrates all the gathered information. In practice, these operations often combine parallel processing, when multiple independent pieces of information can be retrieved at once, with prompt chaining where dependent steps like synthesis and refinement require sequential handling. By structuring workflows this way, prompt chaining turns complex multi-step tasks into manageable, reliable sequence perfect for real-world application. Another powerful application of prompt chaining is in data extraction and transformation. The goal here is to convert unstructured text like invoices or forms into a structured and validated format that can be reliably processed by downstream systems. A typical chain might look like this. Extract fields from the unstructured text such as dates, amounts, or names. Second, validate the extracted fields against expected formats and rules. And third, conditional prompts come into play if validation fails. Here, the agent generates a focused prompt asking specifically for any missing or malformed information. So when the external tools are involved, like in OCR processing, the workflow can become even more sophisticated. First, text is extracted from scanned documents. Then, data normalization ensures all fields follow the required format. Third, any arithmetic or calculations are delegated to external tools or calculators for accuracy. And finally, the precise results are incorporated into the structured output. By chaining these steps, the system can reliably transform messy, unstructured data into accurate, actionable information, reducing errors and increasing efficiency, something that a single prompt could never achieve on its own. Prompt chaining is especially powerful for complex content generation where multiple phases are needed to produce polished output. Instead of attempting to generate an entire document in a single step, the process is broken down sequentially. First, generate topic ideas to establish a direction. Second, create a detailed outline to structure the content. Third, draft section 1 focusing on the initial part of the narrative. Fourth, draft section 2 incorporating context from section 1 to maintain coherence. And fifth, review and refine the complete draft integrating all sections into a final polished output. So this phased approach ensures clarity, consistency and higher quality results while allowing the agent to focus on one task at a time. Another key application is in multi-turn dialogues, where maintaining context is critical. Each conversational turn constructs a new prompt that systematically includes information and entities from previous interactions. By preserving history and context in this way, the agent can maintain coherent, meaningful conversations over extended interactions, handling follow-ups, clarifications, and evolving user intentions without losing track of the dialogue flow. In essence, prompt chaining transforms both content creation and conversational AI from error-prone one-off interactions into structured, reliable, and context-aware processes. Prompt chaining is also extremely useful for complex programming tasks. Rather than generating an entire program in a single step, the agent breaks the task into discrete logical operations, ensuring accuracy and maintainability. Understand the request by generating an outline or pseudocode, write an initial draft of the code, identify potential errors using an LLM or specialized tool, refine and rewrite the code to fix bugs or improve efficiency, and finally add documentation to ensure clarity and reliability. So this step-by-step approach mirrors how human developers work, improving both reliability and the quality of the generated code. Prompt chaining also excels in tasks involving diverse data types like images, text, labels, and data. The chain decomposes the task into, say, the following steps. First, extract text from image or source material. Second, link extracted text with labels to provide context. Third, interpret information in combination with tables or structured data. Fourth, determine the required output based on the integrated insights. So by processing each step sequentially, the agent can handle complex multimodal reasoning tasks that could be unreliable with a single prompt. In both cases, coding or multimodal analysis, prompt chaining enables structured, reliable, and context-aware solution for integrate AI tasks.